Let me tell you how I really feel about it. I
Please.
thought I was being honest.
Rich, thank you very much for joining us here on Approximately Correct. We're very pleased to have you here.
Thank you, Scott. It's my pleasure to be here.
We've been wanting to have you on for a while, so it's great to have you. We've talked about reinforcement learning a few times on the podcast already, but we're interested to hear about what exactly about that reinforcement learning setting was appealing to you. Why did you start working on this?
Well, I was always interested in systems that interact with the world and learn from that. And that's all that reinforcement learning is to me. I mean, you have to have a goal, right, which we formalize as a reward. But it's kind of surprising that if you look into AI, when I started in the 70s and all throughout this time, there really isn't that much that's about, system interacting with the world and learning from it and having a goal.
Mm-hmm.
And even in the early days of cybernetics and throughout pattern recognition and supervised learning, those systems don't have a goal. They're just trying to pick up on a pattern, which is an important part of intelligence, but it's not interacting with the world to have a goal. And so that always seemed like it was kind of missing.
Uh-huh.
There wasn't reinforcement learning when I started. We had to make it because there wasn't anyone doing it.
And was there a particular moment for you that you kind of remember having that feeling of, oh, I think I want to look to this goal-oriented direction?
Yeah, well, it was a gradual moment when we just studied all the different things that people had studied, like pattern recognition, like control theory, all these things, kept looking, where are we going to find the one where you're trying to do something?
Mm-hmm.
And, there was bandits. There were always bandits. Bandits where, you kept doing an action till you get to the most reward. But that was as close as it came. And they didn't have something that says, oh, I remember I should do this in this situation and that in that situation. And in order to get my goal, right? Bandits, you just do one thing over and over again.
Right. It's fundamentally stateless.
Yeah, that's right. It's stateless.
Why do you think it started that way? Why was it all focused on prediction?
Well, it didn't. In my reading of the history, is it didn't really start that way. I think they wanted to do interacting
Mm-hmm.
to achieve a goal. And then they slid back into pattern recognition because pattern recognition is clear and simple. And then they gradually kind of forgot about it. Like some of the very earliest things, 1954, like Farley and Clark, they talked about having trial and error. And then it gradually became supervised learning.
Like a clearer path forward?
It was a clear path, yeah.
Yeah, simplification.
And that's always been the case. I'm sorry to start so far back.
No, it's fun.
It's important to build a foundation.
And it's also one of the nice things about having you on is that you remember.
I'm old. Yes,
you remember
good.
those things. Yeah. Let's move forward though. What are the things you're thinking about in the context of reinforcement learning today? What interests you about reinforcement learning right now?
The only way to describe it is not to talk about reinforcement learning, but to talk about all of AI and what's needed in it, what's happening in AI and what's not happening in AI, what needs to happen. Mm-hmm. I'm still thinking AI is interacting with the world to achieve a goal. And I guess that means we're talking about reinforcement learning. But if you just interact with the world to achieve a goal, then you've got to make a model of the world. You've got to have a goal. You've got to model the world at multiple timescales. You've got to learn what are the right structures and right features and concepts to understand the world. Mm-hmm. And I didn't say, where we start, which is you have to do things. You have to try things and see what works, which is where reinforcement learning starts. So I would say that over the years, we have developed good methods for linear mappings. If you want to learn a linear relationship, then we're fine. We can learn online. We can learn continually.
Could you give an example of one of those linear relationships that would work really well?
So all the algorithms are actually defined for the linear case and for the nonlinear case. You have linear TD lambda, nonlinear TD lambda, Q-learning, you have both linear and, it started as linear versions. And the linear versions learn rapidly and they can adapt as the world changes. But they can't learn nonlinear mappings. They can't learn exclusive OR. They can't learn new features. Okay. So 1986, we found backprop and we started to be able to learn nonlinear mappings. But it was like a devil's choice or whatever. When we had to learn, we wanted to learn nonlinear things, we had to give up the ability to change rapidly and to learn continually. I mean, did you have to? I mean, I don't think you should have to, but the methods that were first found were not able to learn continually, and they were so exciting and powerful. They were able to learn nonlinear things that, we were not dissatisfied to give up the continual learning in return for being able to learn nonlinear maps. That was a good trade-off. And, it was a good trade-off, but we've kept on too long. And more than that, somehow I feel the aesthetics of the field has changed, and the field wants to focus on what they can do instead of noticing what they can't do.
What do you think that is?
So it's just that simple. We can do certain things, and so we could work on those. Yeah. So all of deep learning is all about, hey, what can we do with, we take a data set and we learn from it, and then we freeze our learned system and we display it in the world. ChatGPT doesn't learn at all, but it is highly learned to construct it. And so, we've done language. It's an amazing accomplishment. But we had to give up something that can learn to use language as it's going during use, during normal operation. It's a test of the researcher. Does he want to see what we can't do and try to work on that, or does he see what we can do and go further with that?
It's like this problem of looking under the street lamp, right? Like I've lost my keys, and I'll look under the street lamp because that's where I can see, even though that might not be where
it's like that.
The keys are. Yeah.
Anyway, I think it's fine to do all different things, but I think the important observation is that the field has overwhelmingly gone in one direction, gone towards, and so much so that you're strongly discouraged if you want to say, oh, there's something we can't do. Right. They say, well, yeah, but we can do all these other things, so don't criticize us. Yeah. I see that as a big effect. In the early days, machine learning, it was much more open. Oh, this is interesting. Let's do that. There's that. And then, like, at some point, deep learning, or wasn't the field, went to a stage where, unless you're doing something complicated, at least like Atari, you can't publish.
Right.
You have some new idea. Well, how does it work on a big problem?
Right.
And I think it's gradually easing off. I think there's more interested in what we can't do. And the whole thing about continual learning is exactly the thing that's more acceptable to work on now.
So maybe I'll get you to define, like, what is continual learning? What does that mean?
Continual learning just means that you continue to learn rather than learning in the factory and then being frozen when you go out into the world.
I see.
Sometimes I try to search for, well, if we have continual learning, and that's almost the normal one, well, what should be the abnormal one? The abnormal one, I don't know, I'm trying calling it transient learning. So what deep learning does is transient learning. We learn in a special phase, and then you're done learning, you never learn again. And that's transient learning. That's the unusual one.
Yeah, like episodic learning.
Episodic.
Well, I can't do that because reinforcement learning uses episode in a very particular way.
Yeah.
Can't get past that.
It does kind of strike me as so reasonable. I mean, like when you think of like how we learn, I don't go home and forget everything that I've done whenever I get new information. Most times, but bad day maybe. So I guess I'm kind of curious, like, why was that not sort of the default from the start?
It's just, it was the default from the start. It's just that in recent decades, we've gotten to this groupthink where we all think in a particular way.
Yeah.
So I like to think about it in, what are we trying to produce? Are we trying to produce a system that is fixed and behaves really good? Our final product, will it be something that can continue to learn, that can encounter new things and learn about them? When you come in each day to work, do you think, oh, I'm really good, I just have to do the same thing? Or do you think, the reason they're paying me something is because I can adapt to what happens and I can be flexible and learn new things?
Yeah, most days.
I don't know, they're both important.
Yeah.
But with that adaptability, always seems really important to me. Part of intelligence. Is intelligence a policy, There's intelligence and ability to adapt to whatever happens.
So what are the challenges when it comes to trying to build these systems that can learn continually?
Okay, so this is the first question you asked me. You asked me, like, what is the exciting thing to do now?
Yeah.
And I went in my spiel. The field has gone off and done this trade-off. They can do nonlinear things, but only if they give up continual. That's the way the field has gone very strongly. It's done great success with it. I don't begrudge that at all. I do begrudge it that they don't leave space for working on the other. But I'm a successful academic, and I'm old, and I can do whatever I want. So I'm going to work on what I actually think is the most important, even if no one else thinks it is important. So I think it's time. Well, it's long past time for someone to figure out how you can do continual nonlinear learning. And in my opinion, there's actually no reason these should be opposite to each other at all. Mm-hmm. So I'm doing it in a particular way, focusing on online learning and a single task, just like the world is gradually changing and you have to keep following it and learn in that setting. You just want to fill in this gap. We should be able to do nonlinear learning and yet still be fully continual.
So why can't we? What's the hang up?
Well, I think we just haven't tried.
Yeah.
Yeah.
But like, what are the technical things that are standing between you and
well, so we've created all these specialized things to make transient learning work pretty well. Okay. So replay buffers.
Right.
And this the way we do normalization and like early stopping. We've developed this huge technology and techniques for making the transient learning work. And so that inhibits doing the continual learning from networks because, well, like you're not going to do very well on ImageNet. You're not going to do, because ImageNet is a standard benchmark and it's meant for the transient case. Mm-hmm. You're not going to do very well on Atari right away because we developed all these customized methods to make Atari work pretty well with transient learning methods. It's both the methods are different and the problems are different. Like you can't just step in and do better on the standard problems because all the standard problems are designed for the transient case.
So it almost sounds like you're kind of saying it's time to maybe just like take a step back and look at the wider picture rather than these narrow fixes to...
Absolutely. You can also talk it the other way. You can say, yeah, people don't realize how important it is. That just means it's going to be all the more, and bigger result when it's worked out. Yeah. It's good, not bad to be a contrarian if you can afford it. As I say, I'm lucky I can work what I want and it's okay.
Yeah.
Let me tell you how I really feel about it.
Please.
I thought I was being honest. I thought other people were going to do this. When I was a PhD student, my brother student, Charles Anderson, also a student of Andy Bartow, he did, the nonlinear part. I'm going to work on the reinforcement learning specifics part, and then we'll put them together. It'll be good. And then I'm just disappointed. It's 40 years later, and those guys haven't figured it out. Instead, the nonlinear stuff went off and did offline transient learning, and they didn't give me methods. They didn't give me methods that I could use to learn the policies, to learn the value functions, to learn the models of the world, the transition models of the world. And they didn't figure out representation learning. They didn't figure out, let's figure out what are the right representations for the world, the ones that are going to generalize well and let me learn fast. Now it's absolutely the bottleneck for going forward in reinforcement learning, and I would say in AI. We don't have methods that can learn continually except for the linear case. And we don't have methods that can find good representations. Like we always have to fight against arrogance because arrogance hurts your ability to see truth. But what I'm saying is kind of arrogant. I'm saying, I gave these guys 40 years to figure it out. They didn't do it. So now I'm going to have to do it. That's sort of what I'm saying, which is extremely arrogant. At least the second part, that I'm just going to be able to do it in a couple of years or whatever. I mean, I have been thinking about it for a long time. And I really wish I didn't have to do it. It's such a shame.
Well, they've set some of the groundwork, right? Like the work that they've done isn't completely useless. It will help you.
I feel maybe you're being maybe you're being accurately nice, but I feel like it's not the groundwork. It's actually away from the solution.
Oh, okay.
It makes it harder to do the right thing because they're not saying, oh, this is a problem that we need to solve. They say we've done.
Yeah.
The backdrop paper is about learning representations. They considered that the solution to the problem of how you learn representations.
But shouldn't a representation be general and useful in many situations, and then whatever you need to do, you learn a linear mapping on top of it?
Yeah, I'm good with that. I think that they think that backprop learns good representations.
Okay. I also was assuming that.
And I don't think so.
Okay. Interesting.
Or they say that they have, then it makes it harder for someone to go along and say, oh, this is an unsolved problem, I'm going to work on it. They say, oh, no, backprop did that. And if you're going to work on it, you'd better work, right next to backprop and show you're better than it.
So what's wrong with the representation? What aren't they doing?
So this backprop is just gradient descent. There's nothing in gradient descent which will drive the learning system to find features that generalize well. It just finds features that solve the existing problem well.
So it's not a problem with backprop. It's a problem with the goal, the loss function that backprop is solving.
It's a problem with gradient descent. Gradient descent is just, the objective is just to...
The objective, yeah. It's a problem with the objective.
Right, the objective.
So it sounds like a lot of the work is just convincing people that we don't have the right solution.
Okay, you could do that. This is a way to lose. You say,
okay.
Oh, no one's working on this. First I got to convince people that this is the right thing to do, and then I'll work on it, But no, you'll spend all your time convincing people, and you'll never actually work on it. And so you'll never actually succeed at it. And everyone else will say, oh, look, he says we need to do it, but he's not getting anywhere. It's a good way to lose is to spend your time trying to convince other people that they should do what you think is important.
Okay, so what's the alternative? You just do the important thing and
it's
ignore.
Hard.
Yeah.
You have to be contrarian and actually do it. You have to do it. And you can spend some time trying to convince other people. And you have to if you hope to get published. But
I mean, in some ways, this is what our friends in the nonlinear setting did, right? They ignored everyone for a good decade or so while they all told them that, there was nothing principled about what they were doing. Everybody was in love with their principled statistical machine learning, and they kept plugging away.
Yep, but they always had good results. They always had something to point to that was an advance. Always is too strong.
I remember a time, my early grad school years, there was certainly a lot of noise around deep learning, and also people still thinking it was silly.
Yep.
So anyways, but maybe we might give them a bit of credit for sticking with it.
It's the story of, the wilderness. Neural networks had their decade in the wilderness, so no one thought that was good. So I guess I'm sort of saying continual learning has had its decade in the wilderness, and now it's starting to be acceptable. That's good. And it'll all come back. All these problems with science are self-correcting.
Well, I mean, are they? It takes a person to decide, right? The science itself is the people in it, right? So it's only self-correcting if somebody decides.
And it can take a long time.
Yeah, over what time frame?
Yeah, right.
So we've talked a lot about
I want to do that. These are the decades when we are going to figure out how the mind works.
Okay.
All right.
I'm so happy that it's plural decades.
Well, I think we should strive for 2030, and knowing that we probably won't succeed, but you have to try.
And when you say succeed, like what
understand how the mind works, understand how a system can learn by trial and error, just by trying different things, and make a transition model of the world so we can understand the world. It can find these fulcrums of decision making. Should I go to this talk or that talk? Should I go to the washroom? Should I take a sip of tea? All these, are you have to find those choices. The low-level choices are there, but you have to find the meaningful choices in your life. Right. So all that involves in a model. So it's not too much to ask that we learn by trial and error, and also that we make a model of our world and are able to use that model to plan. That's the set of things that I think make up a mind.
I think also a uniquely human property is the ability to have multiple goals at the same time. I have many things on the go. I could bore you to tears with all of the things that I'm currently working on, right? We all have all of our things that we're doing. We have families, we have careers, we have, friends, we have hobbies, all of these things. And they layer on top of each other. And every day we decide what our goals are. What will be the thing we do today? Sometimes it moves us towards a bigger goal. Sometimes it's just Sunday and it doesn't matter. But
yeah, and you have to find that balance to keep, like, it's sometimes like a house of cards.
But then I think of like animals, like what's an animal's goal? There's perhaps less to the complexity of a goal. They're also less often about some sort of internal reward, right?
I don't disagree with you.
Okay.
But I
That's
think it's both true that there's only one goal, and then there are lots of goals.
Mm-hmm.
So I do believe in the reward hypothesis that everything, all goal seeking, can be well thought of as understanding the maximization of a single scalar externally received signal.
Ooh.
Yeah. As part of achieving that, we pose many sub problems for ourselves. Like I have the sub problem of how I could pick up my tea and get it to my mouth successfully without spilling it and everything else. All these things are sub problems that are really useful for us to solve as part of achieving the overall goal. So I think of the subtasks, sub problems, as a solution method for the single overall problem. And so that lets me have both, right? I have one goal, and yet I also have that the mind of the agent is full of, oh, will this let me do that? Will this let me do that? I've got to learn all these separate things and learn the solutions to each one. And then I'll make my life will be full of, oh, I'll decide to work on that goal for a while, and that'll drive me to end up in some place, and then I can work on another goal. So you think at the level of goals as sub-problems and all these different goals.
And sort of like creating those sub-goals.
Creating them, absolutely. Yeah. You pose them for yourself.
Mm-hmm. PhD. I want to get a PhD. I want to get tenure. I want to...
So in that case, like, what would be the singular goal that those are all sub-goals of?
Well, the singular goal is going to be reward.
Yeah.
We don't really know what people's rewards are, but it's like pleasure and pain, and maybe people's attitude towards you, respect from other people. Mm-hmm. So the amazing claim of the reward hypothesis is that there's one tiny little scalar juice that you're trying to maximize, and then out of that low level, it's a low level thing. It's, listen, a number coming into your mind at each moment in time. It's computed in the hypothalamus. And then out of that comes, like, I want to raise a family. I want to have a career where I'm a successful research scientist, So out of a totally non-abstract thing comes out very abstract goals and very abstract concepts. Now, so there was a time when that was just so inconceivable that it would be embarrassing to say it. But now it should be straightforward. Like we've seen that happen many times, like AlphaGo, learn to play Go, and there's all these abstract concepts. Learn to play chess, and there's all the abstract concepts you need in chess.
Or like language models. It blows my mind what they've learned from this simple
even better, much better.
Little problem. Oh my gosh.
Especially
Predict the next word.
Yeah. From tiny things can come very abstract things.
Okay. Okay. That's a convincing story.
It does. I mean, I'll be honest, when you put it that way, like, it also feels a little psychologically uncomfortable, I'll admit. Like, you sort of feel less complex than I might like feeling about myself.
Yeah. In these decades, we're going to understand the mind much better, and I think it's not all going to be comfortable. I think the fact that it's uncomfortable actually makes me think that we are making progress. We are understanding things better.
Yeah.
We're not just and finding out what we want to be true, finding out what's actually true. And if you think about it, it really wouldn't be possible to make a person who wanted to do something like become a research scientist. Like, how would evolution program you to have that goal, right? It's inconceivable, and it wouldn't work. It's got to give you a goal that it can sense, that's concrete. It takes us down a peg. That's this psychological uncomfort. There are going to be other things that are smart, and we're going to understand how they work, and they're just going to be trying to get this number high, and that's interesting.
It also seems like, kind of, because you were talking about animal intelligence, it sort of erases the
Let me
distinctions.
just
that I think.
object for a minute.
Okay.
Humans are animals.
Sorry, I guess yes, that's fair. Non-human animal intelligence. That I think it's very tempting to think that we are very different, as I just did when I said that. But it might erase some of those divisions that we've set up that don't actually exist, and that's not fun. It's accurate, maybe, but not fun. So you're saying you think we'll have this understanding within the next 6 years at this point?
No, I do have a prediction. Yeah. The prediction is 1 chance in 4.
Of what?
By 2030.
That
we will understand. It's going to be vague, but we basically will understand intelligence, which doesn't mean we're going to understand the human mind. That will take much longer. But we will understand how you can do trial and error learning to achieve a goal, how you can make a transition model of the world that enables you to plan multiple levels of abstraction, and do that with no major gaps. It's going to have to learn good representations, learn to generalize well. It'll be a neural network, just have some different algorithm. It will have a reward.
What is the world?
The world? The world is the thing that we interact with, and we send bits out to.
But do you mean all of this, or do you mean some constructed world?
I think the world is constructed. So it's the world, we send bits to it, and it sends bits back to us, to our eyes and so forth.
Right.
And so we make sense out of this thing that we send bits to and get bits back from.
So you're saying any world, I guess, is what
any world.
Any world.
Yeah. To be able to make models, transition models, so then you're able to plan. If you can plan and you can learn also by trial and error, that is what I think a mind is.
If your prediction holds true, like you said, a 1 in 4 chance, I think you said by
1 in 4 chance, 2030, 1 in 2 chance by 2040.
Okay. What does that mean? Like how will that change things?
We'll understand how minds can work. This will help us understand our own minds. The AI researchers will understand it at its detailed level, and it will gradually filter out to the society, to the consciousness of the world. And we will get uncomfortable feelings, and then we'll gradually get more comfortable. This will have technological changes. It'll change, the economy. And I'm not sure which of these is going to be more important, the sociological or the technical. There are going to be lots of technological changes anyway, even if without understanding the human mind. I think it will change us, really, because we'll understand ourselves better, which is maybe the whole point. So I think that's going to be really profound. Yeah. Totally separate from its impact on the economy, its impact on geopolitics.
Do you think it will impact the way we teach, the way we educate people, if we understand it better?
Yeah, totally. Well, one big thing will happen will be augmentation. If we understand how our minds work, then we ought to be able to add, a better memory. I want to be augmented. I want to think better. I want to. There are many advantages to digital substrate over the biological one. So we could be better. So so many things are held back because we don't know how we work. Now, as I said, understanding minds is not the same as understanding the human mind. It's not the same as understanding the human brain. That will take longer. So, Alana, you're a psychologist. You're on the edge of neuroscience. What do you think of things like Neuralink, brain interfaces?
I mean, I guess I see a lot of the places in which they could be helpful. I just think we're pretty far away from most people feeling like that's the thing that they would want. I don't think that's probably a 2040 thing. What do you think?
Well, in some sense, it's just an interface.
But are there so many other ways to have interfaces without actually opening my skull?
That's true. You can get high bandwidth interfaces in. It's hard to get high bandwidth interfaces out.
Maybe it's about compression, though. Like I often think about if GPT takes your quick summary of what you want to explain to somebody and turns it into a verbose email, and then the person on the other side is taking that verbose email and using ChatGPT to turn it into a summary, why aren't we just sending summaries to each other? So maybe we could do better than language.
Yes, we really ought to be able to better. Language is it's taking your whole thoughts and squeezing them into these words, these linear words.
Yeah.
And it's
Could we
there
do
must be
better?
something much better.
Yeah.
Are you going to be disappointed in that?
If we don't have language?
No, yeah.
Yeah.
Just when we get...
as it came out of my mouth, I thought, that's sacrilege. You shouldn't say that.
Yeah. Yeah. Personally, we're getting back into psychologically uncomfortable
That's right.
territory
That's
again.
right.
I love language, and I think language is, been the way that we communicate these complex thoughts that we have in our minds, and also the way that we think through things ourselves is with language. So I don't think we need to throw it away completely, but I often think about sometimes it's it's more than we need, I guess. Our last question for you is, do you have any tips for students or other budding researchers about research in general, how to choose what to work on, how to make good progress?
Yes, I think I do. Get a research notebook and write in it every day.
Write what?
Write your thoughts and work on your thoughts. Try to, to challenge them and make them better. If you want other people to be interested in what you think, then you should start by caring about it yourself. And you should care about it at least enough to write it down and challenge it and develop it to progress it. That's the most important thing. I hit on that strategy and it really changed my whole trajectory. It's really hard to do because it's a blank page and, what do you have to say? And maybe you're confused about what you're thinking. One saying I've thought to help with that is that usually the value of writing down your thoughts is directly proportional to how vague and confused they are. The value is proportional to how hard it is to write them. Right? If you say, I don't even know how to, I'm thinking 6 things at once. I can't possibly write this down. That's when it will be super valuable, when you do write something down.
Is that a way that you know that you have an idea that you really want to pursue? Is that a sign?
No, that would be scary. It's got to be just like you and the page, and you're trying to be clear to yourself. What are you thinking? If you can't think of anything else to write, just write down, well, what do I think are the 6 interesting ideas that I'm rolling around in my head? So just then write them down, 1 through 6, and then say, well, is that really all of them? Is there a 7th one? Well, these 6 are 2 of them really the same? Or just take another paragraph on each one of those 6 things and explain what you meant by it. Explain to yourself what your thought is. And just by doing that, you will say, oh, no, that thought kind of just disappeared into nothingness when I tried to explain it. Maybe it isn't anything, or maybe it grew and changed as you wrote it down. All those things will happen. And so it's important just to keep writing. Try to do a page a day. Don't stress out it too much, but do keep doing it on a regular basis. That's my advice. Second advice is that you should try to be neutral on what's popular. If it's popular, unpopular, that's shouldn't influence you at all. Because if it's popular, well, then it'll be easier to work on it because people will understand it. But it'll be less valuable because everyone's doing that. So you should be neutral. Pick your problem. What makes sense to you as being important and potentially fruitful.
Do you have any tips for deciding on what is the next thing I should work on?
Yeah. So like I write down the 6 things. These are 6 things that I think are interesting. And then I explain them. And then I go back and say, okay, now let's try to say, which one could I possibly work on now?
And what if there's like 3?
Yeah.
Then what do you do?
The 3 things, write them down.
And keep going until there's only 1? Or?
Oh, no. That's a good question. I don't mean to suggest that you find one thing and you do that. You have to work on a few things because it is research, and some things are not going. Most things are not going to work out and not work out right away. Yeah.
From the sounds of it, you probably go through a lot of notebooks.
I have about 25 of them now.
Like current ones, or
no, it's actually 25 at the time when I stopped using physical notebooks.
Right.
Now I just write on my MacBook.
Do you ever go back to revisit?
Yeah, not as often as you might think.
Yeah.
But you do sometimes, for sure. And now that it's all on the computer, I can search it and find those things even more easily. Do it a bit more.
Yeah. And also it takes up a little less space than a whole bunch of notebooks.
Although there's something pleasing about the row of notebooks.
Yeah. Seems like progress.
Yeah, I would always write in ink.
Brave.
Scratch things out.
Well, I think that's about all that we had, unless there's something else that you wanted to touch on that we didn't talk about.
Well, thank you very much for giving me this opportunity.
Learned a lot. Not all of it comfortable, as we noted, but all of it fascinating. So thank you very much, Rich.
Thanks.